Soalan pertama dalam population genetik ialah state the Hardy-Weinberg principle. Ini kamu kena hafal lah. Hardy-Weinberg principle state that frequency of allele and genotype in a population remain constant from one generation to another generation. Okay, saya ulang. Kalau soalan tanya Hardy-Weinberg principle state that the frequency of allele and genotype in a population remain constant from one generation to another generation. Okay, ini ya. Allele and genotype in a population remain constant from one generation to another generation. Okay, next. List two conditions for this principle to be achieved. Okay, dia ada syarat dia. Syarat untuk kita guna Hardy-Weinberg principle. Okay, syarat yang pertama ialah dia ada 5 syarat. Okay, kamu boleh pilih lah. Dia nak 2 jawapan sahaja. Okay, syarat yang pertama ialah large population. Yang kedua ialah random mating. Yang ketiga ialah no mutation. Yang keempat ialah no migration. Dan yang kelima ialah no natural selection. Pilih 2 sahaja sebab dia cakap 2. Okay, saya ulang. Ada syarat keadaan di mana untuk kita pakai Hardy-Weinberg principle, dia mesti large population, random mating, no mutation, no migration dan juga no natural selection. Okay, ulang balik, apa itu Hardy-Weinberg principle? Hardy-Weinberg principle state that frequency of allele and genotype in a population remain constant from one generation to another generation. Condition for this principle to be achieved, it must have large populations, random mating, no mutation, no migration and no natural selection. Okay, move kepada C. Okay, C. In a randomly breeding population of mice, black coat is dominant to white coats. In a population, 36% have a white coats. Calculates the genotype frequencies of black coat mice in the population. Okay, first awak tak boleh letak dulu. Dia bagi black coat is dominant to white coat. So H besar is black, H kecil is white. Okay, settle. In the population, 36% have a white coat. Okay, before awak tak percaya soalan, make sure tulis dulu persamaan dia. Okay, wajib tulis P plus Q equal to 1 dan juga P square tambah 2 PQ tambah Q square sama dengan 1. Okay, so 36%, apa-apa pun cari dulu nilai Q square. Okay, Q square. Okay, Q square sama dengan, nampak ni 36% have a white coat. So maknanya Q square ni maksudnya ialah frequency of genotype H kecil. Okay, sama dengan Q square. Kalau P square ni sama dengan Q square. Okay, kalau P square, H besar. Okay, so apa-apa pun kena cari dulu nilai Q square, iaitu H kecil. Okay, so nilai dia ialah 36/100. Ni kat sini. Okay, untuk nilai Q square. Kenapa tak boleh cari nilai P square? Sebab dia ada H besar, H kecil. Ini panggil sebagai 2PQ. So dia takkan tepat. So kena cari dulu nilai Q square. Okay, nilai Q square iaitu 36 bahagi 100. Okay, so Q sama dengan 0.6. Okay, maknanya frekuensi of allele H tadi ialah 0.6. Okay, so dia nak cari calculate the genotype frequencies of black coat mice in the population. Okay, black coat mice, dia genotype frequencies dia ada dua, sama ada H besar plus dengan H besar, H kecil. Sebabnya apa? Sebabnya black coat sama ada homozygous dominant ataupun heterozygous. Okey, sekarang ini nak cari ialah ini P square kan? P square. So kamu ambil persamaan P campur Q sama dengan 1. So Q kamu dapat P sama dengan 1 tolak 0.6. Kenapa? Sebab Q sama dengan 0.6. So P sama dengan 0.4. Okay, so maknanya P sama dengan 0.4. So maknanya H ini kamu ambil, ini sama dengan P square, kamu ambil 0.4 kuasa 2 sebab P square ni campur dengan nilai apa? 2PQ. Untuk heterozygous kamu ambil 2, 0.4 dan juga 0.6. Okay, ini kamu akan dapat 0.16 campur dengan 0.48. So dapatlah jawapan dia ialah 664. Ini untuk genotype frequencies of black coat. Okay, saya ulang balik soalan ni. In a randomly breeding a population mice black coat, H is dominant. Okay, H ini nilai untuk P. Okay, is dominant to white coat. Nilai untuk Q. Okay, apa-apa pun cari nilai Q square. Apa itu Q square? Q square ialah H kecil. So dia bagi in the population 36% have a white coat. So ini adalah nilai Q. Okay, calculate the genotype frequencies of black coat. Black coat ni dia ada heterozygous, dia ada juga homozygous dengan nilai P campur dengan 2PQ. Okay, settle? So, seterusnya, in a human population, the frequency of recessive individual for extra long eyelash is 90%. 90 per 1,000. What is the individual percentage of this population that carry recessive allele but display the phenotype of short eyelash? Okay, first kamu detect dulu mana satu yang mana satu yang dominant, mana satu yang recessive. Okay, in human population, the frequency of recessive individual for extra long eyelash is 90 per 1,000. Maknanya extra adalah recessive. Okay, extra ialah recessive. So nilainya ialah 90 per 1,000. So maknanya ini nilai apa? Ini merupakan nilai Q square. Okay, sebab dia homozygous recessive. Okay, Q square sama dengan 90 bahagi 1000. Okay, jawapan dia ialah Q sama dengan 0.3. Okay, apa-apa pun ingat, cari dulu nilai Q square. Dia bagi nilai Q square, the frequency of recessive individual for extra long eyelash 90 per 1,000. Dapatlah 0.3. Okay, and then macam biasa, before that kena tulis persamaan. Okay, kena tulis persamaan untuk dapatkan markah. 2PQ tambah Q square sama dengan 1. Okey. Soalan tanya, what is individual percentage of this population that carries recessive allele? Dia ada recessive allele, but dia menunjukkan phenotype short eyelish. Short eyelish ni ialah yang dominan. Maknanya dia tunjuk ciri dominan, tetapi dia bawa allele recessive. Apa maksudnya? Maksudnya ini merupakan heterozygous. Maknanya heterozygous ni ialah dia ada ciri dominan iaitu short eyelish, tapi dia bawa allele yang recessive. Maknanya nak cari apa? Nak cari 2PQ. Ingat ini kena ingat ni. Kalau A besar, ini nilai P square. A kecil, Q square. Kalau A besar, A kecil, 2PQ. Okay. Kalau A, ini nilai P. Kalau A kecil, ini nilai Q. Semua ni adalah frequency of allele. So, soalan tanya, what is individual percentage of this population that carries recessive allele? Dia ada A kecil, tapi dia menunjukkan ciri A besar. Yalah, A besar, A kecil ataupun nilai 2PQ. So, kita nak cari nilai 2PQ. So, kamu dapat Q. Dapat Q, boleh cari nilai P. P sama dengan 0.7. Okay, ini untuk nilai P, nilai Q. So, sekarang dah boleh cari nilai 2PQ. 2PQ 0.3 darab dengan 0.7 dapat 0.42, dan soalan tanya adalah percentage. Kalau percentage kamu ambil je kali dengan 100%, dapatlah 42%. Soalan kedua sama juga, state 2 assumption ataupun condition of Weinberg Law for genetic equilibrium. Sama juga syarat untuk kita pakai Weinberg principle. Yang pertama ialah large population, sama je, ada 5. Yang kedua ialah random mating, tak perlu explain ya, hanya hafal sahaja. Yang ketiga ialah no mutation. Yang keempat ialah no migration, dan yang kelima ialah no natural selection. Pilih 2 sahaja sebab 2 markah sahaja. Okay, B. In a population, 40% of the babies are born with albino. So albino ni ialah ciri recessive. Calculate frequency of the following recessive allele. Okay, recessive allele maknanya sama dengan, nak cari apa? Cari nilai Q. Okay, so kamu ambil lah macam biasa, tulis dulu persamaan P plus Q equal to 1. So sekarang ni tulis dulu P square campur 2PQ campur Q square. Ingat, tulis dulu persamaan. Okay, lepas tu ambil nilai Q square. Sebab dapat, dia bagi 40% kan. Q square sama dengan 14 bahagi 100. Okay, so Q sama dengan 0.374. Inilah jawapan dia, nilai Q. Okay, dominant allele ini refer kepada nilai P. Dah dapat Q, boleh cari nilai P. P sama dengan 1 tolak 0.374 sama dengan berapa? Sama dengan 0.626. Okay, C. In a population, 1,200 student in a college, only 200 student have a dimple. Having a dimple is a dominant trait. Ingat, dimple dia dominant trait. Okay, assuming the population is in genetic equilibrium, calculate the allele frequency of student with dimple. Okay, sekarang ni apa soalan tanya awak? Awak kena tahu dulu dimple Dominant. Okay, tak ada dimple ialah recessive. So, apa-apa pun kena cari jumlah yang tak ada dimple. Kenapa nak cari jumlah tak ada dimple? Sebab ini akan mewakili Q square. So, maknanya, okay, first nak jawab macam biasalah. P plus Q equal to 1. P square campur 2PQ campur Q square equal to 1. So, nak cari Q square, kamu ambil 1200 tolak 200 okay, bahagi dengan 1200. Okay, kenapa ambil 1200 tolak 200? Sebab 200 ini adalah yang tak ada yang dimple, yang ada dimple. So selebihnya ialah yang tak ada dimple. So Q sama dengan 0.913. Ini jawapan untuk Q. Q ni adalah frekuensi yang ada dimple, yang tak ada dimple. So, lepas tu, dia nak cari frequency of the student with dimple, nilai P. So, maknanya P sama dengan 1 tolak 0.913. Jawapannya ialah 0.087. Okay, ingat soalan ini dimple yang dominant. Tak ada dimple yang recessive. Apa pun nak cari Q square. Q square maknanya ambillah nilai 1200 ini bagi 200 dapatlah 1000. Bagikan total keseluruhan populasi 1200 dapat nilai Q sama dengan 0.913. Q ini mewakili allele yang tak ada dimple, yang recessive lah, allele recessive. Dan P yang ada dimple, iaitu allele yang ada dimple ialah 0.087. Determine the number of student who are heterozygous for this trait. So, kalau heterozygous, maknanya nilai apa? Nak cari nilai 2PQ. Okay, nilai 2PQ. So, nilai 2PQ, okay, nilai 2PQ, kamu ambil saja 2. Ambil P 0.087. Nilai P, nilai Q ialah 0.913. Okay, and then dapatlah 0.159. Jawapan untuk ini berfrekuensi. Dia nak number of student, kamu kena darab dengan jumlah populasi. Itu kamu kena darab dengan 1200. So the number of heterozygous ialah dapat 191. Okay, yang ketiga ialah fur color for a small mammal is controlled by a pair of allele. B for black. B ni adalah P. B, okay. And yellow, B kecil ialah yellow. Q. Okay, 60 individual have a yellow fur. 60 individual have a yellow fur. Maknanya B kecil sama dengan 60. Okay, ini Q square. Okay, and then 1440 individual have a black fur. Okay, black fur ni ada dua genotype. Sama ada dia B besar tambah dengan B besar B kecil, dapatlah 1440. Okay, maknanya ini P square campur dengan 2PQ. Okay, settle. Dan soalan bagi tahu daripada 1440 have black fur, 960 pure breeding. Maknanya B besar ini sama dengan Maksud pure breeding adalah homozygous, maknanya B besar sama dengan ataupun P square sama dengan 960. Okay, faham Itu tak persiaran soalan. Okay, state the Hardy-Weinberg Law. Jawapan yang samalah. Frequency of allele and genotype in a population remain constant from one generation to another generation. Okay, soalan kedua. Calculate the total number of B and B here dan here. So sekarang ini, okay, disebabkan dia bagi semua jumlah allele, dia bagi nilai B kecil 60, dia bagi B besar B kecil, dia bagi B besar 960, dan dia selebihnya adalah B besar B kecil, semua dia bagi. So ini kamu kena guna konsep gene pool, takungan gene. So apa yang kamu boleh buat ialah, tengok ni B besar maknanya ada 960. Okay, so kamu kena darab dengan 2 sebab ini ada 2 allele sebab satu genotype ada 2 allele. Okay, nilai B besar B kecil sama dengan 1440 tolak 960, dapatlah 480. Maknanya jumlah individu yang heterozygous ialah 480, dan 480 ini ialah allele mestilah kamu kena darab dengan 2. Maknanya dia punya allele dia 480 B besar 480 B kecil. Kenapa? Sebab B besar B kecil. Okay, ini semuanya ialah 1920, semuanya ialah B besar sebab dia B besar B besar. Okay, B kecil. Okay, kamu ambil 60 darab dengan 2, dapatlah 120 B kecil. So untuk frequency of allele, B besar, kamu ambil lah ni nilai ini 1920, ambil nilai ini 480. Okay, 480. Kamu ambil nilai ini. Okay, dah lah, cukup dah kan, satu je lah untuk B besar. 1920 campur dengan 480 bahagi dengan 1500, kena darab dengan 2 sebab dia ada 2 allele. Okay, so dapatlah 0.8. Okay, so frekuensi yang kedua ialah frekuensi of allele B kecil. Okay, kamu ambil lah nilai 480 campur dengan 120 bahagi dengan 1500 darab dengan 2, dapatlah nilai 0.2. Itu jawapan dia. So ingat, soalan ini dia bagi semua nilai allele dan juga genotype. So kamu kena guna konsep gene pool. Ingat gene pool, B besar. Maknanya ini ialah merupakan homozygous dominant. So ada berapa jumlah dia? 960. So kena darab dengan 2 sebab satu genotype ada 2 allele. Dapat nilai allele B besar ialah 1920. Untuk heterozygous, dia bagi B besar B kecil, dia bagi dengan 480. So 480 ini bagilah total allele 2 kan. Sepatutnya kamu kena darab dengan 2, tapi 480 untuk B kecil, 480 untuk B besar. Okay, sama juga dengan B kecil. Kamu ambil je 60 orang, darab dengan 2, dapat 120 B kecil. So total semua kena bahagi dengan 1500 kali dengan 2. Sebab apa? Semua individu ada 2 allele. Okay, Okay, next question ialah, if sexual reproduction occur at random, calculate the frequency for phenotype with yellow fur in the next generation. Okay, frequency of yellow fur. Frequency of yellow fur ini dia refer kepada Q square. Okay, sexual reproduction occur at random. So dia akan ikut Hardwood principle. Dia akan sama sahaja dia punya frequency of allele. So kamu ambil sahaja nilai Q 0.2. Q sama 0.2 kan, sebab B kecil ni sama dengan nilai Q. So 0.2 kamu darab dengan 0.2, dapatlah 0.4. Okay, soalan keempat. In the population 700 hamsters, okay, 543 ialah black. The allele for black is dominant. Ini ialah yang dominant, iaitu ini nilai P. Okay, allele untuk P. Okay, over white fur. Okay, white dengan Q. Okay, black ni ialah B besar, white B kecil. So total 700. Maknanya untuk white ada berapa? Ada 157. Okay, dapat dah tafsiran soalan. So okay, black ini maknanya Q square kamu kena cari nilai 157 bahagi dengan 700. Okay, so state the two condition where Hardy-Weinberg's equilibrium is applied. Okay, sama jugalah jawapan dia. Large population. Okay, random mating. Okay, no mutation, no migration, dan juga no natural selection. Okay, pilih dua sahaja. Okay, calculate the genotype frequency of heterozygous in this population. Genotype frequency of heterozygous population. So before that, tulis dulu persamaan dia. Okay, apa maksud genotype frequency of heterozygous in this population? Yang mana satu? Kamu kena ambil cari nilai 2PQ. Dia nak nilai 2PQ. Genotype frequency. Ini allele, ini genotype. So ini homozygous dominant, ini homozygous recessive, ini ialah heterozygous. Okay, so apa-apa pun kena cari nilai Q square. Q square sama dengan 157 bahagi dengan 700. Sinilah kita ambil. Okay, so Q sama dengan 0.474. So dapat nilai P, nilai Q, boleh cari nilai P. P sama dengan 1 tolak 0.474. Dapat P ialah 0.526. So dapat nilai P, dapat nilai Q, boleh cari nilai 2PQ. Okay, 2PQ sama dengan 2 darab dengan 0.526 darab dengan 0.474. So jawapannya ialah 0.499. Ingat konsep sahaja. Okay. Okay, soalan kelima. On St. Helena Island, wingless insects establish beside long-winged insects. Okay, long-winged insects are carrying dominant allele. Okay, long ialah dominant. Okay, in a population. Maknanya long ni allele mesti P lah. Okay, so in a population ada 5,000. Okay, 5,000. Okay, 950 ialah long. Okay, So berapa nilai untuk ada dua kan, wingless. Okay, wingless ini ialah yang recessive. Okay, Q lah. So ada 950 long dan juga 4050 yang wingless. Ingat, long itu dominant, ini yang recessive. Ini nilai untuk Q, ini nilai untuk P. So the frequency of wingless allele, ini dia nak ialah nilai Q. The frequency of wingless allele, nilai Q. Okay, so macam biasa, tulis persamaan dulu. P plus Q equal to 1. P square campur 2 PQ campur Q square equal to 1. So Q square sama dengan, kamu ambil lah 4050 bahagi dengan 5000, jumlah keseluruhan populasi. So Q sama dengan 0.9. Okay, Q sama dengan 0.9. Okay, next soalan ialah frequency of long wing allele. Okay, ni nak nilai P. Sebab P ialah long ni ialah yang dominant. So kamu ambil lah P plus Q equal to 1. P sama dengan 1 tolak 0.9. P sama dengan 0.1. The number of heterozygous insects in a population. So heterozygous, dia ada nilai apa? Nilai 2PQ. So kamu ambil 2PQ 2. P berapa P? 0.1. Berapa nilai Q? 0.9. So dapatlah jawapan dia ialah 0.18. Okay, dia nak the number. Number ni kamu kena darab dengan jumlah populasi, iaitu 5000. Jawapannya ialah 900. Okay, question number 6. Table 1 shows the result of a genetics population study on a population of Drosophila. Normal wing L is dominant over vestigial wings. Okay, L is normal, LLL normal, okay, is equal to P here, and small l vestigial, LL for small l vestigial, okay, vestigial is equal to Q. So what is the frequency of LL L and LL small l normal and vestigial? So now, as usual, you have to write down the equation first. P plus Q equal to 1. Another one is P square plus 2PQ plus Q square equal to 1. So, and as usual also, you have to find out, or you have to find the Q square. Q square is here, vestigial wings. 64 divided by the number of population is 464, and you will get Q is equal to 0.371. So frequency L is equal to 0.301. So you just get the value of Q, so you can find the value of P. 1 minus 3.01, then you will get 0.269. So you have to write the frequency of LLL is 0.629. So B, how many heterozygote Drosophila has normal wing? Shows the calculation. So this question is referred to heterozygous. Okay, the number of heterozygous. So heterozygous is 2PQ. Okay, so now 2P is 0.629, Q is 0.371, so you will get 0.467. Okay, so the frequency of heterozygous. Then how many is referred to number. You just multiple with the number of population 464, then we will get the number of heterozygous in this population is 217. Okay, now see, if all vestigial wings Drosophila are removed from population, so no vestigial wings, so we just only have 400 normal wing, 400 normal wings. Okay, so 400 normal wings. Okay, either it is capital homozygous dominant or heterozygous. So the number of heterozygous we get already is 217. So meaning that the number of homozygous dominant is 183. Okay, because total is for 400s. So how many homozygous dominant are left? How many homozygous dominant are left? So meaning that we have 400 normal wing, because all vestigial wings are removed from population, so we just only have 400. So 400 normal wing consists of either it is homozygous dominant or heterozygous. So normal heterozygous we get already 217. So the left for so we just minus 400 with 217, we get 183 for homozygous dominant. Okay, so now 2, calculate the frequency of LLL and Ls in the new population. So new population we have 400 normal wing. So now B, L, L and LL. So LL we have 1, okay, multiple with 2, because genotype we want to calculate frequency of LL. So LL 100, sorry, okay, 217 L plus 217 L. This one is L. Okay, so the frequency of LL L is 103 with 2, 217, 400 multiple with 2. So you will get 0.73. 0.73. Okay. Okay, this one for LLL besar or capital L, frequency of LL kecil, small l is equal to 217, 400 total population. So we will get 0.27. So here is the answers. Number 7, state the Weinberg Law. Sama je. The frequency of allele and genotype in a population remain constant from one generation to another generations. Okay, so 7b, for sheeps, normal fur is controlled by dominant allele R. So R is normal. Okay, so it's equal to P. Okay, while non-uniform fur is controlled by allele R. Okay, none, this is Q. Okay, in a population of 2000, this one is total population. Okay, that made randomly, is found 500 sheep have non-uniform. This one is Q square. Okay, Q square. By using Hardy-Weinberg's equation, calculate the frequency of recessive allele. Okay, this one is Q. You have to find Q. So now, as usual, P plus Q equal to 1 and P square 2PQ, Q square equal to 1. So Q square, okay, 500, okay, divide by 2000. So Q is equal to 0.5. Okay, so next is the frequency of dominant allele in the populations. So you get already Q 0.5. So using these equations, P is 1 minus 0.5, P 0.5. The answer is 0.5. The number of sheep with normal fur in the population. Okay, the number of sheep in normal fur in population. So normal fur we have R, capital R, either R besar or heterozygous. This one is homozygous dominant, this one is heterozygous. So normal fur, both will display normal fur. So you have to calculate one by one. So RR is referred to P square, this one is referred to PQ. So P square 0.5. Okay, you will got 0.25. Okay, multiple with total population 2000. Okay, 2PQ is referred to 0.5. You will get 0.5 to thousands. So total one, we have 1,500. So the total number of sheep with normal fur in population is 1,500. Question number 8. Thalassemia is an inherited autosomal recessive blood disease in human. Thalassemia major is severe from anemia due to homozygous recessive conditions. Okay, why thalassemia minor is a mild from anemia shown in individual with heterozygous genotype. So meaning that thalassemia is recessive allele. Okay, so it might be Q or Q square. Allele, this one is genotype. So in a population, so we have 12,750. 2 2 individuals are suffering from thalassemia major. So it's equal to 2. Okay, here. So now determines the frequencies of the dominant and recessive allele in the population. This one is P, this one is Q allele. So as usual, you have to write down the equation first. P plus Q equal to 1. P square 2PQ plus Q square equal to 1. So Q square, you will get 2 divided by 12750. So Q is equal to 0.01252. Okay, 5 decimal point, 1 2 3 4 5. Okay, so this one is for recessive allele. Dominant allele, so P is equal to 1 minus 0.01252, get 0.98748 is P. Okay. B. How many individuals will be suffering from thalassemia minor in the population? What is thalassemia minor? Look back at the question. Okay, thalassemia minor, it is heterozygous genotype. So meaning that heterozygous genotype will display thalassemia minor. So what is heterozygous? 2PQ. So you just calculate 2 0.98748 here, multiple with Q 0.01252. Okay, so here is 0.024726. So number, how many is referred to number. So the frequency, you just multiple with the number of population. So 12750. So we got 350 individuals with thalassemia minor. Okay, so if thousands normal individual migrate out of the population, what will be new frequency of dominant and recessive allele? So thousands of people, normal individual, will be migrate out to the population. So look here, I write down first for original population. So number thalassemia, I put thalassemia thalassemia is 2 only. Number of thalassemia minor, just only have 315. Normal, so we have 12433. This one is original population. Okay, original populations. So now new population, after thousands of people that normal migrate out from population. Okay, the number of people who have thalassemia also 2, thalassemia minor also 315. Okay, normal, you just minus 12433 minus with 1000, you will get 11433. So the frequency of allele is based on this new population. So now, frequency of dominant allele. Okay, frequency of dominant allele. So you will get Q square is equal to 2.11433. So you will get Q is equal to 0.01357. Okay, so Q 0.01357, and then for P you just minus 1 minus with 0.01357. You will get the answers. Calculate yourself. Question number 9. Red eyes in Drosophila are dominant to white eyes. Okay, red, white. Okay, red is dominant, white is recessive. Okay, total population is 5,000 Drosophila. Okay, 450 have white eyes. Okay, 450. So one is Q square. Assume that the population is in Hardy-Weinberg's equilibrium. Calculate the frequency of recessive allele or the value of Q. So as usual, P plus Q equal to 1, and then P square 2PQ plus Q square equal to 1. So Q square is 450 divided by 5,000. You will get Q is 0.3. Okay, Q is frequency of recessive allele. Calculate the frequency of homozygous dominant genotype. So homozygous dominant genotype is referred to P square. Okay, so P 1 minus 0.3. Here P is equal to 0.7. So P square is equal to 0.59. 0.59. Okay, calculate the number of heterozygous. Heterozygous is referred to 2PQ. So number you have to multiply with the number of population. So now 2PQ to 0.3, 0.7. So 0.42. So 0.42 multiple with the number of population is 5,000. You will get 2,100. The number can tulis the number of heterozygous Drosophila. Okay, 2,100. Okay, question number 10. State 3 assumptions of Hardy-Weinberg's law for genetics equilibrium. Okay, the answer is going to be same. First one is large population. The second one is random mating. The third one is no mutation. The fourth one is no migration. And the last one is no natural selections. So you just pick 3 out of 5. Okay, because 3 marks here. So write the Hardy-Weinberg equation. So P plus Q equal to 1 and P square 2PQ plus Q square equal to 1. So number C, in a population of thousands of humans, 99% are normal, while the rest have sickle cell anemia. So normal is dominant. Okay, sickle cell anemia is recessive. Okay, even though the question never state that sickle cell anemia is recessive, but you have to know if in human populations sickle cell anemia, thalassemia it is recessive in human populations. So normal is dominant. So now we have thousands of humans. So meaning that 99% are normal. So you have to calculate the number of humans who have a normals. Okay, 99%. So you will get 9990. Okay, so 99990. Okay, here. Okay, so from thousands of human, 990 are normal, and the rest is 10 who have sickle cell anemia. So from 1000, 990 is normal, and 10 have a sickle cell anemia. So look at the question. Calculates the frequency of recessive allele, Q lah. Okay, so as usual, you have to write down first the equations. So it's Q square, get 10 divided by 1000. Okay, so Q equal to 0.0001. So number 2, calculate the frequency of dominant allele in the population by using these equations. P is equal 1 minus 0.001. So P is equal to 0.9999. Okay, the MN blood group. So the MN blood group is codominant allele. It's a type of codominant allele, meaning that both allele are fully expressed. Okay, system 1, dependent on the inheritance of pair of allele. Okay, the table 1 shows 3 different blood group from a sample of people living on an island. So M, MN, N. So we can't use Q square, P square whatsoever. Why? Because of this allele is codominant allele. So both allele are fully expressed, meaning that both allele do not dominant over another allele. So we just calculate here frequency. Okay, we just calculate by using gene pool, because the questions give to you the M, N and MN. So we can't calculate the frequency or allele of M and N by using gene pool. So now, okay, how to calculate the frequency of allele M? So look here, M 238 multiple with 2 because a pair of allele. Okay, here plus with 152 because this is heterozygous. So 152 for M, 152 for N. Okay, settle here. Okay, and then you just add 238, the number of population, 152 and 26 multiple with 2. Okay, so you will get 268 divided by 832. So the frequency of allele M is 0.7548. Okay, So I repeat again, this one is homozygous, this one is homozygous, so MN only. MN is heterozygous, so 152M, 152N. Okay, no. Okay, now from frequency of LLM, so we calculate the frequency of LLN. So here 152, okay, because heterozygous, 152 for M, 152 for N, okay, plus with 26 multiple with 2. Here you have to multiple with 2 because it is homozygous recessive homozygous. Okay, so divide by multiple with 2, so you will get 204,832. So the answers is 0.2452. Okay, number 12. The body color in fruit flies is controlled by a pair of allele. The allele for grey is dominant. So here is P over the allele for ebony is Q. Okay, in a population of 2000 fruit flies, 320 have ebony body. So here is Q square. Assume that the population is in Hardy-Weinberg's equilibrium. Stakes the Hardy-Weinberg's equation. Okay, P plus Q equal to 1, P square 2PQ plus Q square equal to 1. Okay, calculate the frequency of LLE and capital E and E small alleles. So frequency here, Q square first. Q square is equal to 320 divided by 2000, the number of populations. Q is equal 0.4. So you have to write down the frequencies. Don't left the answers like this. Okay, you have to write down the frequency of E equal to 0.4, because if you don't write this sentence, okay, pemeriksa dia tak boleh tahu sama ada dia adalah E besar ataupun E kecil. So make sure you write down the frequency of E kecil equal to 0.4. So and then P is equal to 1 minus 0.4. So P is equal to 0.6. You have to write down the frequencies of E is equal 0.6. Okay, make sure write down frequency of small e, frequency of capital E. Number 3, calculate the number of heterozygous individuals. So heterozygous individual, it will represent 2PQ. So now 2, P is 0.4, Q is 0.6. So the frequency of heterozygous is 0.42. Okay, 0.42. Sorry, 0.48 here. So the question asks you the number. So meaning that the frequency, this frequency must multiple with the number of population 2000s, and then you will get 960 individual, which is heterozygous. Okay, define gene pool. Okay, gene pool is the total number of allele at all loci in every individuals in a population. So I repeat again, What is gene pool? The total number of allele at all loci in every individuals in a population. State 2 Hardy-Weinberg equation. It's going to be same. P plus Q equal to 1 P square plus 2PQ Q square equal to 1. Okay, the allele for black feather in chicken B is dominant over white feather B, small b in a population. This one is Q, this one is P, this one is Q. In a populations, 5,000 chickens, number of population, there are 950 black feather chickens. Blacks meaning that, okay, this one is P square plus 2PQ. Okay, 950 blacks. Okay, so now by using Hardy-Weinberg equation, calculate the frequency of white feather allele. White feather allele is referred to Q. So now you have to find out Q square. How many Q square? So 5,000 minus with 950, you get is 4,050. So this is the number of white feather, okay, or Q square. Okay, the number of Q square. So now you get Q square is equal to 4050 divided by 5,000. You will get Q is equal to 0.9. Q is equal to 0.9. So the frequency of white feather allele is equal to 0.9. So what is the frequency of the black feather allele? So frequency of black feather allele is referred to P. So P plus Q equal to 1. P is equal to 1 minus 0.9. So 0.1. So the frequency of black feather. Next is the number of heterozygous chicken in the population. So the number of heterozygous refer to 2PQ. So 2 0.9 multiple with 0.1, so 0.18. So the number of heterozygous is 0.18 multiple with 5,000. So we'll get is 900. Okay. So if all the white feather chicken were killed by a disease and black feather chickens were allowed to mate randomly, calculate the frequency of dominant and recessive allele in the new population. So as you know that black feather, okay, black feather consists of either P square or 2PQ. So the number of heterozygous 2PQ is equal to 900. Okay, 900. So meaning that the number of P square is 50, since black feather is only 950. So from 950 it consists of P square or homozygous dominant or heterozygous. So since we have know that the number of heterozygous 2PQ is equal to 900, we calculate already. So the number of P square or homozygous dominant is 50. So the number of Q square is 0 because white feather chicken were killed by a disease. So now the new population consists of 900 of 2PQ and 50 of P square. 900 of heterozygous, 50 for homozygous dominant. So how to calculate the frequency of allele dominant? Okay, frequency of allele dominant So you just calculate 50 here, multiple with 2. Why? This one is referred to A. Okay, this one is referred to AB. Sorry. A. So now, how to calculate frequency of allele dominant A? So meaning that 50 multiple with 2 plus with 900, because you can't multiple with 2 because 900 is capital A, 900 is small a. So divide by the number of population, 950 multiple with 2. Okay, so you will get 0.5263. Okay, so frequency of allele dominant. Okay, frequency, the second one, frequency of recessive allele is equal to, so we just add 900, okay, divide by 950 multiple with 2. So the answer is 0.4737. 14. Long wings in Drosophila are dominant to vestigial wing. Okay, so long wing is allele for dominant P, vestigial allele Q. So in a population of 10,000 Drosophila, so this one is the number of populations, 550 have vestigial wings. This one is referred to Q square. Assume that the population is in Hardy-Weinberg's equilibrium. Calculate the frequency of recessive allele. It's referred to vestigial allele. Okay, or Q. So Q square is equal to 550 over 10,000. Before that, as usual, you have to write down the equation. P plus Q equal to 1 and P square 2PQ plus Q square equal to 1. Okay, so Q is equal to 0.2345. Okay, now calculate the frequency of homozygous dominant genotype. It is referred to P square. So you just get the Q. So you can calculate the value of P by using this equation. P plus Q equal to 1. So P is equal to 1 minus 0.2345. So you will get 0.7655. So now P square, you just multiple with 0.7655. So the answer is 0.5860. Okay, frequency just of homozygous dominant. Okay, so now calculate the number of heterozygous Drosophila in the population. Number of heterozygous Drosophila. So 2PQ heterozygous. So 2 here 0.7655, Q 0.2345. So the answer is 0.8972. So we just multiple with the number of population because the question asks you number, so you have to multiple with the number of population. Multiple with 10,000, what you get is 8972. So the number of heterozygous Drosophila in this population is 8972. State 3 exceptions in the Hardy-Weinberg's equilibrium. So now, as usual, there are 5 exceptions in Hardy-Weinberg equilibrium. The first one is large population. Okay. Random mating. No mutation. No migration. And no natural selection. Okay. State the Hardy-Weinberg's principle. Okay, as usual, the frequency of allele and genotype remain constant from one generation to another generation. Okay, so list 3 conditions for his principle to be achieved. There are 5 conditions. Okay, so you just list out 3 from 5 conditions for his principle to be achieved. So the first one is large population. Second one is random mating. The third one is no mutation. Fourth one is no migration. The last one is no natural selection. Okay, state the Hardy-Weinberg's equation. So the first one is P plus Q equal to 1 and P square 2PQ Q square equal to 1. Okay, B. A population of pigeons which is in equilibrium consists of 49% copper colored feather and 51% white colored feather. The copper colored feather is determined by recessive allele Y. So meaning that the coppered color allele is referred to Q. Why? The dominant Y allele determined by white color feather. This one is allele for white color feather is P. So calculate the value of P and Q in this pigeon's population. So Q square is here 49%. Q square coppered color feather, because white color feather is P. It is dominant character. So now, as usual, before you calculate the value of P and Q, you have to write down the equations first. So now Q square is equal to 49 per 100. So the value of Q is 0.7. So you can calculate the value of P. 1 minus 0.7. P is equal to 0.3. Okay, calculate the number of pigeons with genotype heterozygous, Y, and homozygous recessive. So now this one is referred to 2PQ, this one is referred to Q square, consisting of 600 of pigeons. So now for Q square, you just 0.7 Q square, 0.7 Q, so is equal to 0.49. So 0.49 you multiple with 600. Okay, so the answers is 294. This one for small p, small y, homozygous recessive. So for y, for capital Y and small y are heterozygous, so 2PQ to 0.7, 0.3, so 0.42 for y capital small y, so 0.42 multiple with 600, you will get 252. This one for capital Y and small y.